Hi everyone. In today's lecture we will discuss about how massive are supermassive black holes. Although we can't put a black hole on a scale to figure out how much it weighs, we can still measure its mass. Kepler's laws of orbital motion apply to planets, stars and black holes. If we can find a star orbiting a black hole at the center of a galaxy, we can determine its mass. The best example is the black hole that is known as Sagittarius A steric or Sag A star that is located at the center of our galaxy, that is the Milky Way. It is possible for astronomers to observe stars orbiting in the region within a few light years of the center of our galaxy. This is an image of Sagittarius A. Astronomers Andrea Ghez and Reinhold have observed the stars orbiting Sagittarius A star for over 20 years, providing detailed evidence for the existence of a supermassive black hole in our own galaxy. This is represented by this image. In 2020, they shared the Nobel Prize in Physics with Roger Penrose. The star SO2 takes 15.9 years to make one full orbit. When a star travels on an elliptical orbit, the distance a that appears in Kepler's third law is equal to half of the length of the long axis of the ellipse. In the case of SO2, the value of a is 1000 astronomical units. Mass of Sagittarius A equals 4 million solar masses. If you compare the distance between Sagittarius A and the orbiting star to our own solar system, 1000 astronomical units will be well beyond the orbit of the planets, extending into the region where comets orbit the Sun. The closest star to our Sun, Proxima Centauri, is 200,000 astronomical units distant. So, this is a gigantic mass packed into a tiny volume of space. Whatever is located at the center of our galaxy can't be stars, since we would be able to see them if they were there. A black hole is the only plausible way to get such a large mass into such a tiny volume. The Event Horizon Telescope is a radio telescope that is observing supermassive black holes. In 2022, the Event Horizon Telescope team released this image of the innermost region of our galaxy. The dark region in the center is known as the black hole's shadow and is slightly larger than the black hole's event horizon, as represented by this image. The Event Horizon Telescope astronomers measured the size of the black hole's shadow and found that the size agrees with the Schwarzschild formula prediction using the mass of 4 million suns. Our galaxy's supermassive black hole is actually considered a small fry in the heavyweight vision, compared to other galaxies' central supermassive black holes. The giant elliptical galaxy M87 has a black hole at its center that is approximately 7 billion solar masses. The black hole at the center of M87, that is known as M87 steric, was the first black hole to be imaged in 2019 by the Event Horizon Telescope team. The similarity in the images of these two black holes give us extra support to the no-hair theorem, since their main properties only seem to study depend on masses of the black hole, as represented by this image. Students, this is all about this lecture where I have discussed about the masses of supermassive black holes. Thank you so much.